Hi guys. So, we are beginning with oral radiology series. Now, oral radiology begins with X-rays. The X-rays were discovered in November 1895 by William Röntgen, father of oral radiology is Edmund Kells. Now, coming to X-ray machines. Now, to understand the X-ray machine, we need to know how does X-ray machine makes X-ray, how does it work. To understand this, we will have to look closely at the various components of the X-ray machine. Cathode and anode. Are the two main components of the X-ray machine. When we switch on the electricity, the filament present at the cathode, it starts heating up and it produces electrons. Now, when we shoot the X-ray, the electrons from the cathode, they flow to the and strike to the anode, which results in the production of X-rays. At cathode, a molybdenum focusing cup is present, which is negatively charged and parabolic in shape. Also note that cathode itself is also negatively charged, and the anode target is positively charged. Also note that cathode consists of tungsten element and a molybdenum focusing cup, and at anode we have a, a tungsten target and and we also have a copper stem embedded in that tungsten target. The gamma rays have got the shortest wavelength and they have got the highest energy. So, as the energy of the charged particle or the photon increases, the wavelength of the electromagnetic radiation decreases. Now, what happens at anode? When the electrons from the cathode strike the anode, there is deceleration of the fast moving electron, which results in Bremsstrahl's radiation. The electron decelerates due to its attraction towards the positively charged nuclei. Now, characteristic radiation is called characteristic because it is characteristic to the element on which the electrons are falling, or characteristic of the element which is producing the X-rays. So, what happens in characteristic radiation? The, the electron from the target ends up knocking off an electron and it and it falls the electron is knocked off, resulting that the electron is ejected, and a higher level electron falls into the lower level space, and the energy difference between the two shells is actually a fixed amount of energy, and this energy is emitted in the form of X-rays. Now, about filtration, one more. Yes, so increasing this size causes the beam to be less divergent, rays to be falling over there, rays coming at a point. So when we increase the distance between the object and the film, this causes beam to be less divergent and falling more like perpendicular to the film, which increases the sharpness of the image. Now coming to KVP, MA and exposure time. Now MA and exposure time leads to increased density or increase in the number of electrons falling on the anode, hence leading to increased number of X-rays being produced. Now KVP is responsible for the quality of electrons and hence also responsible for the quality and the mean energy of the X-ray beam. Now nothing other than KVP can alter the quality of the X-rays. This is one point you should note definitely. And also note one thing, that increasing KVP not only increases the number of X-ray photons, but it also increases the mean energy of the X-ray photons being produced. Now, radiation is of two types. There is electromagnetic radiation, which we have already discussed, and then there is particulate radiation. The constituent particle or the constituent unit of electromagnetic radiation is photon, and the constituent unit of particulate radiation can be the particle which is being produced. It is a form of particle which is already present in atom. Example, electron, proton, or as in case of alpha rays we have helium nuclei, then we have beta rays and cathode rays. And EMR we have already discussed: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, cosmic rays, and highest energy gamma rays. Now, what is the meaning of linear energy transfer? Now, rate of loss of energy from a moving particle happens in case of particulate radiation. So, here basically the moving particle is being stopped from the matter present in its path, and the moving particle will transfer its kinetic energy to the substance which is stopping its movement. So higher the linear energy transfer, higher is the biologic effect, and lesser is the dose required to produce harmful biologic effect. Now note that alpha rays have got a higher LET, so naturally they would be more damaging to the biological system. Now, Heal effect. The X-rays, as they are produced, the intensity of the X-rays are not uniform throughout. We have higher intensity of X-rays at cathode and we have a lower intensity of X-rays at anode. This is due to self-absorption property shown by self-absorption of X-rays shown by anode. Now, Heal effect increases as the size of the X-ray film increases. So, in case of IOPS that we are shooting, Heal effect is not that much. Now, half value layer. Half value layer depends on voltage or kVp of X-ray tube. So, the greater would be the voltage, greater would be the half value layer required to reduce the number of X-ray photons by half. So, as you can see in this picture, if 2x amount of X-rays were present at the left side of this before crossing this object, now only x amount of X-rays are present after crossing this object. This is called as the half value layer, as it is reducing the number of X-ray photons by half. Now, coming to inverse square law. Inverse square law states that intensity is inversely proportional to the square of distance the electromagnetic radiation or beam is crossing. Right? So, this is the inverse square law for electromagnetic waves. So, we have this formula that I1 upon I2 is equals to D2 upon D1, D2 square upon D1 square. So, I is the intensity, previous intensity, and I2 is the final intensity, and I1 is the intensity present at a distance of D1, and I2 is the intensity present at a distance of D2. Now, these are few formulas of radiation physics. Energy is given by Hc by lambda, where H is a Planck constant, C is the rate of speed of light divided by lambda. Lambda is nothing but the wavelength. And h mu, this mu is nothing but the frequency. Now, the exposure time is directly proportional to the square of distance divided by kVp and the Ma of the X-ray machine. An inverse square formula we have already discussed. Now let's discuss some questions. To see the incipient carious lesion, do we increase or do we decrease the kVp? Answer is that we have to decrease the kVp, as you want to increase the contrast to be able to see the things that were not otherwise visible on our X-rays. So we decrease the kVp. Now, to increase the quantity of X-ray produced, you have to increase which parameter? So the first thing to note is that quantity of X-ray produced depends on Ma and exposure time. So it is depending on both. But if we have to choose one parameter, then we have to choose Ma, as Ma causes increased heating of the filament and hence causing increased amount of thermionic emission. And also one thing to note that the 99% of the electrical energy is actually converted to heat energy, and only 1% of it is actually used to make the X-rays.